Hi, this video is about the development of geometric thinking, and we want to take a look at how that develops through what's called the Van Healy theory of geometric thought. And here's a diagram of it from your textbook. I want to spend a little bit of time talking about what does this mean. As your teacher, what is your goal as far as development of geometric thought, and then how can you help your students move up these levels that we see in this theory. So what is this all about? The Van Heelys proposed that students tend to think about geometric objects at different levels. And the first level that they think about is what's called visualization. They can take a look at different geometric shapes and see them and think about these individual shapes, and they work strictly at a visual level. They don't think about the properties of the shapes or definitions or anything like that. They just see the shapes, and they can talk about what the shapes look like to them. The main thing that kids tend to produce at this level, so still inside this bottom rectangle, is classes of shapes. And so they start to see these same shapes over and over again, these ones that have three sides, over and over again, and they can start to think about them collectively as triangles. And so that's the very earliest kind of geometric thought, is to go from just looking at individual shapes and being able to start connecting them together. Once again, they're not doing this based on properties or definitions. They're doing this based on what do the shapes look like. At the next level of thinking, so inside this next rectangle, in what's called the analysis level, they can take these classes of shapes and start to think about the properties of those shapes. So they know these things are triangles, they know they all look something like each other. They can start to say, what's true about all these triangles? They always have three sides. And that's the beginning of some level 1 analysis type of thinking. I can talk about triangles and say, oh yeah, these triangles all have three angles. And so we've moved from just looking at them and saying, hey, they look like triangles, to saying, here's some specific properties. Next up, students move towards informal deduction, and you can see now they've moved from thinking about class of shapes to properties. In level 2, they take these properties and they begin to think about relationships among those properties. And we'll take a look at an example of how we might push students to do that, or what an example might be of that in a bit. Really, up to this second level is really mainly what you're doing in the elementary levels. At level 2 and above, we're starting to talk about middle school level and into high school level. So a lot of high school geometry is based around level 3 deduction. They're taking relationships among the different properties and thinking about them systematically. And finally, the highest level of rigor means we can take these systems of properties like Euclidean geometry and analyze those and look at features of an entire system, and that's a higher level of thought. So your main focus, what's your goal as a teacher? You're going to have kids down here at this 0 level, and your goal is to move them up the levels. Mainly by the end of elementary school, we want all kids working pretty well at level 2, even starting to look at level 3 type thinking from time to time. So how do we do that? How do we help students move up levels? Well, the main thing to do is to understand what kids think about at the level they're at, and what the products of thought are, and give them activities to actually create those products of thought. So if you have students at level 0, they can look at shapes. You want them to think about, how can I classify these shapes together? So you give them a bunch of shapes and you say, put these into groups. Tell me why you know these are groups of shapes. What makes these the same, or what makes them different? Here's another type of activity to think about. If you've got kids at level 1 moving up to level 2, they know about properties of shapes, but they haven't coordinated those and thought about relationships. So what do? You say, okay, we've looked at a lot of properties of this shape, rectangles, let's say. It's got all these different things that we know. Now you ask them to coordinate them. Suppose we want a shape that we know had some of those properties but not all. Which properties would you need in order to guarantee the shape would be a rectangle? They've got to start coordinating these. So for each level, you look at what's the object of thought and what are we trying to produce, and ask your students to do that. And that's the main way to do it.